All right, so these are very different kinds of problems, but this shows me your understanding of what's going on. So you're making one graph to put all of these pieces together. So I'll try to use different colors so hopefully we can see what's going on. So this says as I'm going towards 3, going towards x equals 3, the y value is going towards 1. So let me put 3 here. So if I'm going towards 3 from the positive side and the negative side, the y value is going towards 1. It doesn't have to be defined there at 1, so I'm just going to make it go like this. Going positive side, going towards 3, the y value is going towards 1. Okay, so let's look at this. This says as I'm going towards the x value of 7, from the negative side only, right? Going from the negative side only, the y value is going to negative 2. So I'm just going to have it coming down towards negative 2. So this part here, this one's black. If I'm going towards 7 from the positive side, the y value is going to 0. So it looks like that. And I'm just going to encourage you to leave open dots as you're drawing them, and then later on if you need to fill it in, then you can. All right, so this is saying at x equals 7, the y value is 0, so we can fill that in. At x equals 3, the y value is negative 2, so I've got a flying dot there. And so then I'm just going to encourage you also to join the graphs together if you can, and then just kind of fill it out. So this is a one picture that satisfies all these criteria. In the end, do take a moment to just make sure it passes the vertical line test to be a function. Let's try another one of those. All right, as x's are going towards 2, this says the function, the limit of the function is 4. So it's 2 from the positive and the negative side. So from the positive and the negative side, the limit is going towards 4. So I could have it coming from both directions there. I could have it coming from, so it's just going towards 2, right? I could have both directions coming up here like this. It doesn't matter. Lots of options. It's not a unique graph by any means. All right, so this is talking about the number 5. So I'm going to put the number 5 over here. I'm going towards 5 from the negative side. I'm going to the y value of 1. So I'm just going to have it go towards 1. If I'm going towards 5 from the positive side, I'm going towards the y value of 2. I'm going to have it look like that. And I'll just join my graph together and just show that that one goes off and that one goes off. All right, so what does this say? At x equal 5, the y value is 1, so it fills in right there. And f of 2 doesn't exist, so they want me to leave that as an open hole. All right, one more, right? Yeah, I think that's it. Oop, oh dear, where'd it go? Okay, come back. Okay, so let's just do one more. All right. So I forgot to mention, I like to scope out and see what numbers I'm looking for. So I've got -1, so I'll put that on my graph, and I've got 3, so I've got that on my graph. So it's kind of nice to scope out and see what numbers that I'm going to need on my number line. All right, if I'm going to -1 from the negative side, so that's this way, I'm going to -infinity. So I'm moving on down. Doesn't have to start here, but it does have to go towards -infinity. If I'm going towards -1 from the positive side, I'm going up towards positive infinity. So it does look like the -1 is a vertical asymptote. All right, so let's look at 3. If I'm going towards 3 from the positive side, I'm going to the y value of 4. So I'm going to have it come up here, go to 4. If I'm going to 3 from the negative side, I'm going to the y value of -2. And then at 3, at x equals 3, the y value is 0. And at a -1 doesn't exist, so I'm going to leave that. So I'm just going to join my graph together in between, and there is my function. Oh dear, what happened? Here we go.